I want to find the value of x and y in this particular figure. So if I evaluate what I have, it looks like I have an isosceles triangle on the top here and a different isosceles triangle on the bottom. The x's appear in 3 places. 30x plus 13 deals with an angle, and 28x plus 27 and 40x minus 9 deal with the legs of the top isosceles triangle. So what I'm going to do is focus on the legs of the isosceles triangle to find the value of x. I'll use that value of x later. So I need to say 28x plus 27 equals 40x minus 9. Now I start combining my terms. I will subtract 28 from both sides to get the x's together. So 27 equals 12x minus 9. I'll add 9 to both sides. So 36 equals 12x. And finally, I'll divide both sides by 12 and have x equals 3. Now, I found the value of x, which is what I wanted to do. But in order to find the value of y, which is down here, I'm going to have to know some angles in this smaller isosceles triangle. So I'm going to plug in the 3 in for this 30x plus 13. So 30 times 3 is 90, plus 13 is 103. Since this triangle is isosceles, these base angles have to be congruent, which means that I can figure out the measure of those base angles by doing 100 minus, or 180 minus 103, and then dividing that by 2, and getting 77 over 2, or 38.5 degrees. There are several things that I can do from here to figure out the value of y. I have a linear pair here between this 38.5 and 5y minus 1. I also could say that 5y minus 1 has to equal 103 plus 38.5. Either way, I'll get the same answer. I'll use the exterior angle theorem, and I'll say 5y minus 1 equals 103 plus 38.5. (103 plus 38.5) is 141.5. I will add 1 to get 142.5. And then I'll divide by 15. When I divide both sides by 15, I get y equals 9.5. And that would be my 2 answers, x and y. Again, it's okay if your answers end up being fractions or decimal.